Hello everyone and welcome to my channel Maths with Lazy Bee. In this video, we'll be discussing a question of Jee Advanced, which is from the topic of differentiation. So the question says that we have two functions f and g, which are defined as follows, and we have the composite function f of g inverse. So we just need to find the value of the derivative of the composite function at 3.2. So this is what we need to find. So they have mentioned G inverse in the question. So for inverse of a function to exist, we should be knowing that whether the function is 1, 1 and onto. If the function is both 1, 1 and onto, then G inverse exists from the codomain to the domain. So let us find out whether the G function is actually 1, 1 or not. So you need to take two values, real values, and evaluate G at both these points and then equate them. Let gx1 equals to gx2. This implies 4 upon 1 plus e raised to power minus 2x1 equals to 4 upon 1 plus e raised to power minus 2x2. This implies this gets cancelled, and cross multiplying the terms, you get this, and you can apply the natural log on both sides. You will be getting x1 equals to x2. So you can see that G is 1, 1, and you can also check for onto. To check onto, and since G is defined from R to the interval, you need to take any arbitrary value in this interval, and you have to find a real number for which to find. This is to find x in R, for which gx equals to y. That is, or this implies 4 upon 1 plus e raised to power minus 2x equals to y. This implies 4 by y minus 1 equals to e raised to power minus 2x. You can simplify it further. Now, in order to find x, because we are proving that this G is onto, so you just need to find x. Now you know that y is in this interval. This implies y lies in this, is greater than 0 and less than 4, and this is strict inequality. This implies 4 minus y is also greater than 0, strictly greater than 0. This implies 4 minus y upon y is strictly greater than 0. Since this 4 minus y upon y point is strictly greater than 0, that means you can take the natural log on both sides without any problem. Because you know that there is the negative numbers, negative real numbers are not included in the domain of logarithm. That is the reason we have to check this explicitly. So if you can take logarithm on both sides, you'll be getting this. And taking this in the denominator, you get the value of x, and you can see that x is a real number. So for any value in 0, 4 interval, you are getting an x for which this holds. So that means our function is onto. G is onto. Since G is both 1, 1 and onto, you can conclude that G inverse exists. Although you don't need to check all these things in the exam, but you should be having an idea so that the concepts remain clear every time. Okay, so we have G inverse. The existence of G inverse is proved. Now you have to find this to find your answer. And this is just a mere application of chain rule. So in order to evaluate this, 2, by chain rule, this is given by this, the derivative of f at this point given and the product multiplied by this G inverse derivative at the 2.2. Okay, so that means you need the derivative of f as well. So f is defined as this. Fx equals to log e square plus 2x plus 4. So this is a very small observation, or because x square plus 2x plus 4 equals to x plus 1 square plus 3. You can break this into 1 plus 3 and you can see that this is greater than 0 every time. This is strictly greater than 3 and this is strictly greater than 0. So this means this is always positive. So that is the reason we can apply log on this function, because it is never negative or 0. It is strictly positive. It is strictly greater than 0. So okay, this was just an observation. This was just an observation, and now you have to find the derivative of it. So you can use chain rule again. You have to use chain rule again and again in this question. So f prime is given by, using chain rule, it is the derivative of the log function is 1 by x. In this time, this is the entire x this time. So we have this, and now the derivative of the inside function, which is x square plus 2x plus 4. So this gives 2x plus 2, and this is the derivative of the function f. Now what else do you need? You need the derivative of the function g inverse at the point 2. Now you can directly use chain rule here also. You don't need to find out the g inverse function. You can use chain rule. Okay, so we have, since this is the inverse of g, so we have g inverse g as the identity function. Now using chain rule, you have to take derivatives on both sides. So you will be getting you took derivative of g inverse at this point, and you took the derivative of g and took the product. And the derivative of this is nothing but an identity function from R to R. Because g is from R to 0, 4. So g inverse will be from 0, 4 to R. So g inverse g will be from R to R. Okay. Now, using inverse function theorem, or you can see it directly as well, that if you are able to take this in the denominator, then you will be able to find this value of g inverse, the derivative of g inverse at this point will be given by this. So, but for this to be taken in the denominator, you should be having this value as non-zero. So if you take the derivative of this function g, which is given by this function g is given by this, and you can take the derivative. And then the derivative of this function. This is given by 8 into e raised to 2. So this is the derivative of g. Now we can easily see that this function is never going to be 0 because exponential function is non-negative and this is never going to be 0. It is non-negative or it is strictly positive. It is positive everywhere. So for this function to be 0, the numerator should be 0. And for numerator should be to be 0, this has to be 0 and this is never 0. This is never possible. Okay, so this is every time non-zero. So the g prime can be taken in the denominator for any value of x. And this is the reason g inverse derivative exists. But you need to find out f of g inverse at the point 2. So g inverse 2. So you should know what actually g inverse 2 is. Now, what do you mean by g inverse of 2 or at the point 2? So g inverse 2 is some y. This implies that 2 equals to g of y. So basically you need to find y for which g acts on y and you are getting the value as 2. So according to the definition of g, we have this. This implies 2 equals to 1 plus e raised to power minus 2y. This implies e raised to power minus 2y equals to 1. This implies y equals to 0 because exponential function is 1 only when this minus raised to minus 2 y is going to be 0. This means y has to be 0. So y is 0. So this implies g inverse 2 equals to 0. Now it is just to be substituted. So this is f prime of 0. And this, according to our calculation, g inverse prime, this is 0. So you get 2 here because g0 is 2. And substituting 0 here. So you get f prime 0 upon g prime of 0. So if you find out this by substituting 0 here, you get 0, 0, 0, you get 1 by 2. And for g prime 0, you get 8 upon 4 because this is 0, this is 1, and this is 2. So the square becomes 4 and you get 2. So this is half and this is 2. You get 1 by 4, which is nothing but 0.25, which is your final answer. So we didn't just solve the question, we actually understood the complete concept. We derived the chain rule, we derived the formulas of g inverse gx. We derived the formula for the derivative of g inverse using the chain rule. And also we saw that y is f well defined, and also we saw that y is g invertible because g is both 1, 1 and 1, 2. So thank you so much for watching this video. This is your final answer 0.25, and see you in the next video. Happy learning.